So today we're going to be recording the week 7 math quiz. This quiz I find it needs less time to solve than last week's quiz. So I doubt time is going to be an issue in your next AMS. Anyways, they gave us a curve with this equation. Now, they asked us the value of dy by dx at the point where x is 1. Now, if you have an integral calculator, throw it into your calculator, you're going to get 15 as your answer. If you don't, we use quotient rule. Now, quotient rule states that it is u prime v minus v prime u. And no, you cannot switch them. You can't put v prime u before u prime v, or you're going to get the wrong answer, over v squared. Now, first of all, let's find the one on top is u and the one on the bottom is v. Now, what's u prime? U prime is 15 prime, which is equal to 0, and v prime is gonna be 2 minus 4x prime, يعني the derivative of it is just negative 4. So 0 times v, which is 2 minus 4x, minus negative 4 into 15. So 0 times anything is just 0, and negative 4 times 15 is 60, or negative 60. So negative make positive, so it's 0 plus 60, which is just 60, over v squared. V squared is 2 minus 4x squared. Now when you substitute 1 into this, you're gonna get 60 over 2 minus 4 times 1 is 4, so 2 minus 4 is negative 2. Negative 2 squared is just 4. 60 divided by 4 would equal to 15. Now that's our answer for part A. Now for part B, it's a bit different. We have a point. I'm gonna erase part A so I can have more space to solve. Now we have a point that moves along a curve, this curve, with this equation. Oh yeah, by the way, we need to save the derivative. The derivative was, so dy by dx equals to 60 over 2 minus 4x squared. Now, what's it called? Now we have the point that moves along this curve, and it has on this point, on this curve, you have a point called A. Now, once your moving point reaches point A, the x coordinates increasing at a rate of 0.3 units per second, so this is for x, and the y coordinate is increasing by a rate of 0.5 units per second, so this is for y. Now, these are very small changes in x and y, right? So we call these delta x and delta y, because they're very small changes in. And that's why delta, delta as this, but lowercase delta in Greek is written like this. That's why it's a small change. Anyways, now we have a rule we need to memorize, which is small change in y equals dy by dx, which is the derivative of your curve, times a small change in x. So far, very easy. Okay, so now we have our formula, and now we just need to fill in our numbers. We said that, I don't know why this went and the error went, I accidentally deleted them. Anyways, so we have our delta y being 0.5 equals 60 over 2 minus 4x all squared times 0.3. Now we next move, we're gonna put x on one side, or the thing with x on one side, and 0.5 times 0.3 on the other. So it's 0.5 divided by 0.3. Because to get rid of it from both sides of the equation, you divide by 0.3 on both sides, equals to 60 over 2 minus 4x all squared. And now when we have this equation and we reach this point, we will cross multiply. So it's 0.3 times 60, which is 18 once you put it onto your calculator, equals 0.5 is basically half. So half times 2 minus 4x all squared. So this is basically like this. Now 2 times 18 is 36 equals 2 minus 4x all squared. Now how do we get rid of the squared? We put both sides under a radical sign. So 2 minus 4x equals either, it could equal positive 6 or negative 6, because every square root is either the positive or the negative of that number. Now let's solve for x if x was 6. So 2 minus 4x equals 6 would give you negative 4x equals 6 minus 2, which is 4. Then x would equal negative 1. And now if x, let's solve right here for 2 minus 4x equals negative 6. Then you'd have negative 4x equals negative 8, and then x would equal to 2. So here in green, we can tell that x equals either negative 1 or x equals 2. These are the two possible x coordinates of A, and that's how you get your answer. That's it for question 1. Let's move on to question 2. Now here it's the same concept but implemented in a slightly different way. Now here they want you to find the equation to estimate this value. I am actually going to estimate this value so you could understand why we're using this equation. Now they told you you have a function that is expressed by this equation. Now as the estimate of the value of f of 2.02 using f prime x is used by this equation. Now for this, I want you to ignore everything here and leave it to your last part. Now usually, first of all, we need to remember the formula I gave you last time. Small change in y equals dy by dx times small change in x. Okay, now that everything's set, we have our values to start solving. So the estimate of the value, now you don't have, they didn't give you dy, nor did they give you dx. But what really is the function of 2.02? What is 2.02? Isn't it just 2 plus 0.02? Yeah, it is. So basically, it's x is just expressed by the x we want, because this is the function at x, which is 2.02. So x is basically this, right? So we want to find the function at 2.02. To find the function at 2.02, can't we just find the function at 2.02 minus the function at 2? We can. So we're gonna find the small change in y is just 0.02. The small change happening in y is 0.02, or the function at 0.02. But what they want us to do in this question isn't use our calculator and find the value of this function using our calculator at 2.02. They want us to estimate. So we're gonna estimate the function when the small change is just 0.02. So the function at 2.02 minus f at 2 is equal to the derivative, which we're going to find to be 2 times 5, which is 10x minus 2 at 10x minus 2. And what's the small change in x? Now usually sometimes they're going to tell you the small change, but if they don't tell you the small change, you can infer that it's this number. 0.02 is very insignificant. So times 0.02. Now we have all our given. right? Now we have our entire equation. You're gonna say, okay, now what the hell do I do with this? So we do not know what this value is, right? So we're gonna use it to find. So we're gonna keep it the same since we don't know what it is. We're trying to estimate its value. So f.202 minus f of 2. Can we find it? Yes. We just substitute 2 into this equation. So 5 times 2 squared, which is 5 times 4, is equal to 20. Minus 2 times 2, which is 4. So 20 minus 4 is 16. 16 plus 3 is 19. So f of 2 is 19. Equals 10x minus 2. Now when we say x, we want the big number. We want x, not the small change in x. So we want 10x minus 2, and where x is equal to 2. So where this is equal to 2. So 10 times 2 is 20 minus 2 is 18. So they want us to find 18 times 0.02. 18 times 0.02 on your calculator. 18 times 0.02 is basically 0.36. So now we could rewrite this again. I'm gonna rewrite it up here. So it's f of 2.02 minus 19 equals 0.36, right? So f of 2.02 is basically equal to 36, because you moved 19 to the other side and added it. So this, oh yeah, and by the way, I've been using the sign wrong the entire time. You need to write the estimate sign because you're estimating. These are not real values. So my bad, let me actually change it, because in the written parts we actually do need to write the estimate value. I don't know if they're going to be removing marks for it, but it's the estimate. So f of 202 is nearly 19.36. So now we did not need to solve it. The question didn't ask us to solve it. I just solved it because I feel like in the exam they're probably going to ask us to solve it. So now what we're going to do is we're going to go back to using this one. So they want the equation. Let's compare what we have. We have f202 on this side, and this isn't minus, by the way. This is just like me writing at start, whatever. And 19, like we have here. But here we only have 18 on this side. So where did they move the 0.02? They moved it here. They moved it here. So when you move it to the other side of the equation, it becomes 1 over 0.02 times all of this. And now we could remove it from this side. So basically, we can rewrite our entire equation as 1 over 0.02, because we moved it from the other side. We moved our small change in x, times our function of 2.02 minus 19, which is 2f of 2, is giving us approximately 18. And that is how you find your answer. So basically, I just found the answer for fun, but we needed to use the equation to find this answer. And that's it for this question. Let's move on to our next. The rest of the exam is pretty straightforward and easy. Here you have a curve C. Oh yeah, and by the way, the rest of the quiz we've taken last year, but we've taken it fully, which is the table of derivatives, but this year we took double derivatives, so it's like a bit additional information. Anyways, the curve whose equation is given by this equation, it has a local maximum and a local minimum. Find them. So what we do, first of all, you find f prime of x, which is equal to 3x squared minus 6x. That's it. This is our f prime of x. Now we know that f prime of x equals to 0. So then we could just use by substitution 3x squared minus 6x equals 0. Now onto your calculators, you go on to mode. Every calculator has this, by the way, mode 5, then press 3, It can depend on your calculator. Like calculators without the integral sign, most of them it's mode 3-3. But on calculators with integral, it's mode 5-3. You're just trying to find the mode with quadratics, or the mode called equation, and the one that's for quadratics. Then you could just put 3 into your and just like write it down into your calculator. You're gonna get that x is equal to 2 and x is equal to 0. Now here is where we need, like with our given, we need to draw our table of variation. So now we could draw at x and at y prime. So we have two stationary points, 2 points that make this equation 0, or the slope 0. Because the function the derivative gives us the slope, and we just found where the slope is 0. So now it could either be at 0 or at 2. 0 is before 2, so you write it before 2. And this ranges on from negative infinity to infinity. Now, we know at 0 and 2, it is 0. Now, before 0, when you substitute, let's say, now I'm going to give you a trick, and I'm going to tell you like how to actually do it if you do not have a quadratic, or if you have more than a few values. You substitute any number, you substitute into this equation any number less than 0, then any number between 0 and 2, then any number larger than 2. So any number less than 0, let's exchange negative 1. At negative 1, so 3 times negative 1 squared is just 1, so 3 times 1 is 3, minus 6 times negative 1 is positive 6, so it's 3 plus 6, which is a positive number. So you write down here positive. Now let's do a number between 0 and 2. Between 0 and 2, let's say 1. So 3 times 1 is 1, minus 6 is negative 3, so it's a negative number. Now let's say a number after or bigger than 2. A number bigger than 2 would be 3. So let's say 3 times 3 squared, which is 9. 3 times 9 is 27. 27 minus 6 times 3, which is 18, is going to give you a positive number. So it is positive after this. Now you add like a little extra line. Now wait, before I do the rest, my little trick, like the trick, it's not like it works for every quadratic. You look at your original function, or no, you could look at this one. This is a, right? If a has a positive sign beside it, the middle between the two values is going to be the opposite. But if a had a negative sign, here it would be, in the middle it would be positive, and on the corners it would be the opposite of the middle. So let's say we had negative 3, it would be a negative, positive, negative. If we had positive 3, it's going to be positive, negative, positive. You got it? So you always, for the middle, it is the opposite of A's sign, and for the edges, it is like A's sign. That's just a little trick for quadratics to like save you time instead of substituting 3 values. Now, when it's positive, then it becomes negative, then it goes back to being positive. So it goes up like this and then like this, kind of. This isn't really how it has to go, but I'm like just explaining. And here's point 0 and here's point 2, technically. So this would be a local maximum. I'm gonna say max like here. And this would be a local minimum. Okay? Why do we call it local? Because it is local to this time interval. It is local, or not time interval. It is local to 0 and 2. It is local to this part of the curve. We don't know if this is the full curve or if this is just a part. So we call it a local minimum and a local maximum. So this is our local maximum and this is our local minimum. At point 0 is a local max, and at point 2 is a local minimum. So let's write it down so we can like actually solve the question. Now, the local maximum is at x equals 0, and its value there is Now here they say, and its value there is 13. You're gonna say, oh wait, what? How'd they find that? What you're gonna do basically is just substitute 0 into this equation. So 0 cubed is 0 minus 3 times 0 is 0 plus 13 is gonna be 13. That's it. That's literally how you found it. And they asked you then for the local minimum at 2. And there they didn't ask you to substitute any value or find its y coordinate. So it's just 2. And that's it for this question. Let's move on. Okay, now here we have a question asking about velocity and whatever. We took this before in math last year, especially if you did the IG, you're supposed to know this. And we did it also in physics mechanics, so we should already know this, but I'm gonna solve it. A particle moves along the x-axis so that at time t seconds, its displacement from the origin is x meters, where x, so this is the position of the p. Now, the velocity, so we have x. Now, velocity is equal to x prime, acceleration is equal to either v prime or x prime prime, the double derivative of x. Keep these in mind. Velocity, so is x prime, right? So you just do the derivative of this equation. It's gonna be 3t squared minus 24 plus 45. That's it for part A. Now, give the two values of t, where t1 is less than t2, where the particle is at rest. You're gonna say, okay, what does at rest mean? At rest means velocity is equal to 0. At rest means velocity is 0. Whereas when it tells you origin at O, which they tell us here is the origin, when it's at origin, x is equal to 0. Just keep these two keywords in mind, because they can be confusing. So we need to find when the equation of v is at 0. What do you do? Into your calculator again, because this is also a quadratic, so it's 3, then you put minus 24 into mode 5, 3 or 3, 3, whatever it is in your calculator, and then plus 45. So just write 45. And then you're gonna get points. You're gonna get that x is equal to, or in this case, you can't call it x because our thing is t. So t is equal to either 5 or 3, where v is at rest. Now, you can accept both of these times. Why? Because if you had one of them that's negative, you cannot accept that because there's no such thing as negative time. Now, they told you t1 is less than t2, so we know that t1 is 3 and t2 is 5. Now they want the distance of p from the origin at this time. So what do? You replace this number into the original equations. You're gonna get that the distance of p from O at 3 is 4, and then here it's 0. Now the particle is at the origin when t is... Okay, what the hell did I do? Wait, I'm gonna pause. Sorry, I just clicked the thing in the corner. Anyways, so the solving all went. Anyways, we reached where we have to substitute here into here and here into here. Now they want when the particle is at the origin. What you do is you go to mode 5, 4. Now, like you need to go to mode 5 and then 4 to put in the cubic function. So it's gonna give you the answers. Like all calculators can do this, by the way. So, and even calculators with non-integral can do it. So they're gonna allow you to do it in the exam, definitely. When you do this, you're gonna get time 2, and then you're gonna get time 5. And either way, we could have known time 5 was gonna be one of them, because look, at 5 seconds, the distance was 0. 0 meters means the origin, so we could have just guessed 5. Anyways, the particle is at O when t is 5 and t is 2. So then now they ask you the distance traveled by p between those two times is. Now, when you substitute their values into x, you're gonna get that x is 0. The position is 0. So the distance traveled theoretically, or like by logic, is 0, right? Wrong. When you substitute the two values, you're gonna end up at 0. They're at 0, but that's their displacement. But doesn't mean that's the distance they traveled at these two times. And in the previous question, We found out that these two values reach at rest at 4 meters, and at 5 it goes back to the origin. So at 0 seconds, it's probably at the origin. At 2 seconds, it probably traveled, and by 5 seconds, it probably went back. So what do we know? We know that probably from 0 to 3 seconds, it went and traveled 4 meters. And between 4 seconds and 5 seconds, it traveled back another 4 meters. It traveled back to the origin. So it went from the origin in 3 seconds and reached 4 meters. And by 5 seconds, it went back to the origin. So what do we know? That the distance traveled is 4 meters and back from 4 meters. So it is 2 times 4. So it's 8. That's the distance traveled. Moving on. Now, here is the start. These questions are going to show up a lot in the MS, I'm sure of it. Now, look. The radius of the sphere is increasing at this rate. When the radius is 3, find the rate of change in volume. Now, we need to translate everything we're reading. The radius of the sphere is increasing at a rate of 4 over pi centimeters per second. So it is, the radius means we're gonna find the rate. So it's the derivative dr, big R for actually small r, is increasing at rate of something per second. So it's dr by ds. S is rate, r is radius. Okay? So it's dr by ds is equal to 4 over pi. Right? Now they want the rate of the change of volume. So change of volume per second means dv by ds. Right? I'm just naming it s for seconds. You could name it anything you want. I don't recommend naming it r because you have radius and rate both starting with an r. So they want what's the change of volume. So they want what's dv by ds, and you have given dr by ds. So do you also have another given? Yes, you do. You have a given of dv by dr. You're gonna say, where the hell is that? You have the volume of a sphere. Oh, they named radius big R. So you could change the r's here to like big R, because that's what they named radius. Both work. I'm not saying that it doesn't work. Both work. So dv by dr, which is the derivative of the function of the volume. This. So you derive it. 4 over 3 times 3 is 4 pi r squared. So what is this? It is dv by dr. Right? So to find dv by ds, it is basically dv by dr times dr by ds. Right? Because dr by dr cancel, and then you're left with v over s, right? So what you do is dv by ds equals to dv by dr, which we found to be 4 pi r squared, times 4 over pi. Then pi cancels with, pi cancels with pi, and then you're left with 16 r squared. Now they told us the radius is 3 centimeters. So you do 16 times 9. 16 times 9 is supposed to give us 144. Wait. 16 times 9 gives us 144. So our change in volume is going to be 144 centimeter cubed, which is volume per second. And by the way, you could always guess what it is by the unit. Centimeter by second means it's radius per second, and centimeter cubed is for volume per second, so that's dv by ds. You could always guess. You're gonna see more questions, so if you didn't understand this one, you can understand the rest. It's okay. Okay, here we have another question about distance and displacement and velocity. So this is the displacement, and x is in meter, t is in seconds. Now the velocity of the object after 3 seconds is, so we need to derive. So it's 1t squared plus 4, right? So after 3 seconds, you just substitute 3 times 3 squared is 9, 9 plus 4 is 13. Now the acceleration is the derivative of velocity, which is 2t. Acceleration equals 2t. That's it, right? So they want the acceleration at 6 seconds. So at 6 seconds, by the way, when they tell you at a number of seconds, it is the instantaneous acceleration or instantaneous velocity. If they ask us for average or between a time interval, it's solved differently. But let's focus now, they're asking us on instantaneous acceleration, so 2 times 6 is 12. Here they're asking us for average acceleration. When they ask you for average acceleration, you do not need the acceleration formula, you do not need it. You forget it, you look at the velocity equation. You replace t into the velocity equation both times. You replace when t equals 3 and t equals 6. Because what do we know velocity is from mechanics? It is v final minus v initial over the change in time over delta time, right? So we basically just do, we replace 6 and 3 into this equation. So t at 6 is 6 squared, 36 plus 4 is 40, minus 3 squared, 9, 13, we already found it, over 6 minus 3, which is 3. You're gonna get 40 minus 13 is 27, divided by 3 is 9. So that's your average acceleration. And the acceleration at 0, the acceleration is 0. So a equals to 0 when t equals 2t. So t equals 0. You could get that pretty easily. Moving on. The curve C, whose equation is given by this, has an inflection point at x equals. Now, when you hear the word inflection point, you need to think of one thing: double derivatives. It's always, when you hear the inflection point, you derive twice. So its first derivative is going to be 12x squared. That's fx prime, f prime x. Doesn't matter. And then f prime prime x is going to be 24x. Now to find the inflection point, you find where f of double prime x is equal to 0. Then 24x then equals to 0. So when is the inflection point 0? The inflection, what's the inflection point? The inflection point happens when x equals 0. And that is it. Moving on. Now, identify the turning points using the, okay, never mind. You could solve it in many different ways. This is question 8, okay. So, consider this function, and you need to find the local minimum and maximum. So first of all, we need to derive. So just, it's y prime is equal to 6x squared plus 12x minus 48. So now we derived it. Now what do we do next? We draw our table of variation. But what points do we write? Oh wait, no, sorry. Next is y prime equals 0. And then we do 6x squared plus 12x minus 48 equals to 0. And then onto your calculator, we put all these values. So it is 6, 12, and then negative 48. And oh wait, sir, I mixed up. I'm still on mode 5-4. So anyways, 5, 3. So now 6, 12, negative 48. You get your x values to be 2 and negative 4. So you draw your table of variation, x, y. Okay. So there's 0 at negative 4 and 2, right? Now, what did I tell you about the little trick for quadratics? This is positive, so the middle is negative and the corners are positive. And that's it. It's correct every single time, I promise. Now to check, it goes positive, negative, positive. So this point would be your local max, and then this point would be your local min. Now they want you to give them the full point of the local minimum and the local maximum, so you're gonna replace -4 and positive 2 into this equation, and you're gonna get the second points. Or actually they gave you the second points, it's just you need to replace them to find out which goes to which. So our local minimum is 2. Actually don't even need to replace, because they told you local minimum at this point and local maximum at this one, simply. Now for part B of the equation, we just need to store our... Now we just write y prime again, because we need it, equals 6x squared plus 12x minus 48. Now we need to do y prime prime, double derive, to find the function. You need to find, if you want to find if it's concave up or concave down, like that's another thing that tells you to find double derivative. It's an inflection point also. So y prime prime equals to 12x plus 12. That's it. Now you need to find what makes y prime prime 0. So it's 12x plus 12 equals 0. 12x equals 12. Wait, this is positive 12. So it's 12x equals negative 12. So x equals -1. Okay? So this is our inflection point. So now we just draw a little graph like this, and this is -1. Now you substitute into this equation the double derivative. When 12x is less than 1, you just replace like -2. Let's say -2. -2 times 12 is 24. -24. -24 plus 12 is a negative number. And when what's it called? It's a number bigger than -1, like 0, so it is a positive number, because 0 plus 12 is positive 12. Now it is concave up when here, so when it is larger than -1, and it is concave down if and only if it is smaller than -1. So it's concaving up, which means it's positive when x is larger than -1, and it's concaving down when x is smaller than -1. That's pretty much it. Now let's move on to our next question. Okay, so here we need to do the same thing with the rate and not rate and whatever. So the side of a cube, so side, it increases at a rate of 3. So we need to like directly translate. So d side over dr, which is rate, is equal to 3 centimeters per second. Now the rate of the increase of the surface area of the cube. So they want the rate of surface area. So d SA over dr, right? They want that. We don't know that. And they want it when the side is 6. Now we need to also find another thing. We need also d of SA over d of s, right? Now this is the surface area of a cube. Is basically, the cube has 6 sides, and the area of one side is s squared. So the surface area is 6s squared. That's surface area. Now surface area prime equals, or basically not surface area prime, like dsa by ds is equal to the derivative, so it's 12s, right? So now we have everything we need. So dsa, you usually always start with the one that has the rate of the volume or the surface area first, always. It's easier to work with. dsa over dr, and you're gonna see how in a later question near the end, equals d of s over dr times d of SA over d of S. So this was given as 3, this was given as 12S, and we need to find now. And then you find it is 36S. So the derivative of SA in respect to the rate is 36S. Now they told us they want it when the S is 6. So you just replace 6 into this, so 36 times 6 is equal to 216. And that is your final answer. Let us move on to our next question. Okay, so here they told you the distance in meters traveled by a car after t seconds is given by this equation. The acceleration of the car at 2 seconds, which means they want the instantaneous acceleration. And this is the distance. So we said that acceleration is equal to x prime prime t equals acceleration. So we derive this twice. So first derivative is going to be 3t squared plus 1t, or just plus t. And that's it. And then we derive again, that's x prime t. And now x prime prime t is equal to 6t plus 1. Now we want at 2 seconds, so we just substitute 2. So 6 times 2 is 12, plus 1 is 13. And that is it. Moving on. Okay, so now again, you have this curve. We first derive it. And here, wait, in this question, they only want local, they only want local maximum and minimum. So we're only going to have to derive once. So it's y prime equals to 3x squared minus 36x plus 81. That's it. Now we need to do y prime equals 0, and then 3x squared minus 36x plus 81 equals 0. And then, oh yeah, by the way, this is the first question. It's asking you to derive it. And then you could take 3 out and leave you with. Now listen, what I usually do is I put this into my calculator, and you're gonna get the answers to be 3 and then 9. So it is x minus 3 and x minus 9. So that's a trick. But you could also take 3 out and leave it to be like x squared minus 12x plus 81 being, what's it called? 81 divided by 3 is 81, not 91. 27. And then you just factor it, and then it'll be x minus 3 x minus 9 equals 0, and then answers x is equal to 3 and x is equal to 9. And here they did the table of variation for you, and they just left B blank so you don't cheat for the first question. And now the curve C has a local maximum. So here it's up, down, up. So when it's up, then when it goes up then down, this is your max or local. Remember local, because I'm not gonna write it. And this is your min. So our local maximum is at x equals 3, and our local minimum is at x equals 9. Moving on. Okay, so the position of x in meters at time t seconds of a particle is given by this equation. Find the values of t for which the particle is at the origin. What did I tell you? Origin means x equals 0. So basically, you do this equals 0 into your calculator. You go on mode 5-4, and you start substituting values, or writing them down in your calculator. And it's gonna give you the numbers. So t is equal to 7, half, and 0. And these are your seconds: half, 7, and then down here 0. Moving on. Okay, why is it? Anyways. Given x of t and v of t represented respectively by the position and the velocity of a moving particle at x, how do you find the average acceleration? What did I tell you? Average acceleration, you do not need to find the, what's it called? You don't need to find the derivative of acceleration. You don't need to find the derivative of velocity, nor do you need to find the derivative or double derivative of acceleration. So to find the average acceleration, it's either the change in velocity. This is the definition of average acceleration. It's the change in its velocity divided by the change in time, or the time it takes, which can be represented by v final minus v initial at, or like v at t or whatever, minus or divided by the change in time. So this is basically very easy. Here, this is wrong, but if it wrote x prime tb minus x prime ta over tb minus ta, this would be correct. This is correct, this is wrong, because they only wrote position. This is how you'd find the average velocity, not the average acceleration. This is average acceleration, this is just velocity, and this is instantaneous acceleration, not average. By the way, we write average as bar over it, but this is just acceleration. Displacement over the time taken is average velocity, and this is average acceleration. Moving on. In which interval is the graph of f of x equal to negative... okay, so this is just asking you when is it decreasing. So what you need to do is you just derive it. So it is negative 3x squared plus 27. And then you do y prime equals 0, and then this you equal it to 0. You should have gotten that by now. Negative 3x squared equals negative 27. And then it is x squared equals to 9. And then x squared, x equals either 3 or negative 3. So now we write the table of variation. xy at 3 and negative 3. And we told you when it is a quadratic, you look, the sign of a is negative this time. So what's the middle? It's positive, and the edges is going to be negative. So this is decreasing, then increasing, then decreasing. So when is it decreasing? It is decreasing before negative 3 and after 3. So when x is smaller than negative 3, or when x is larger than 3. And that's it. Moving on to our next question. Okay, f of x has a point of inflection at x equals a if the double derivative of the function changes sign as the graph passes through the point of affliction. What does this mean? That when you find the double derivative, if it goes positive to negative or negative to positive, then this is a point of inflection. If it stays positive to positive or negative to negative, it is not a point of inflection. Like this it is, like those it isn't. So f of x doesn't change sign. First of all, it's not f of x, it's f double prime x. And then it has to change sign. So this is wrong in two different ways. F of a equals 0, wrong. It is f double prime a equals 0. F double prime x doesn't change sign is wrong. F of a equals 0, this is nothing to do with anything. F double prime of a equals 0, yes, this is how you find the point of inflection. And this is how to make sure it is a point of inflection. Moving on. Now this question again is another question where we have to find rate and whatever. Now, we have the volume of a right circular cone of base radius r and height h is given by this equation. Now they're telling you that the hollow right circular cone has a height 9 times the radius. What can we use with this information? We know that height equals 9r, right? We're gonna need this later. So now you want in terms of r, you do not want any h in this equation. What's the volume? So they're basically telling you, my bad for moving, like my chair is slipped. So they're basically telling you make this equation only in terms of r. So what do? We were given that height equals 9r. So what can we do? We can replace height by times 9r. 9 times third is equal to 3. R times r squared is equal to 3 cubed. So it's 3 pi r cubed. And that is our volume equation for this case. Now dv by dr, so dv by dr is equal to dv by they called rate t, sorry, my bad. They want dv by dt, so it's equal to dv by dr times dr by dt, right? So dv by dt is equal to dv by tr, which we found right now. dv, oh yeah, wait, we didn't find yet. So this is our volume. Let me rewrite this because I didn't actually. So the derivative of the volume, which is dv by dr, is equal to this derivative. So it's 9 pi r squared. So in this equation now we could replace dv by dr by 9 pi r squared. So dv by dt equals this, right here in this green box. So it is 9 pi r squared by dr by dt. Now moving on. Water is leaking from the bottom of the cone at a rate of 4 centimeter cubed per second. So dv by dt is equal to leaking. Leaking means it's getting less, so negative 4 centimeter per second. Centimeter cubed per second. And centimeter cubed is a unit of volume, and second is dt, so you know it's dv by dt just from that. Now when the height of the water is 18 centimeter, what's the radius? Didn't we say height equals 9r? So when height is 18, r is 2. That's it. Now at this time they want the rate where the radius is changing. So we know that dv by dt is equal to negative 4. And we know that dv by dr is 9 pi r squared. And now we need dr by dt, which is the unknown here. So dv by dt equals dv by dr times dr by dt, right? So dv by dt can be replaced by negative 4. dv by dr can be replaced by 9 pi r squared. dr by dt is to be found. Now they gave us the radius to be 2, so we can replace here this by 2. So it's 2 squared, which is 4. 4 times 9 is 36 pi. So what can we do now? dr by dt equals, you move 36 pi to the other side by dividing it on both sides. So dr by dt equals negative 4 over 36 pi. Which you can simplify by doing this 1 over 9, and that is your final answer. You're going to say, where's the negative? Here's the negative, and here's 9 pi. And if they didn't write the negative, it would be negative 9 pi, because you have to have the negative sign. So this is your final answer. Now let's move on to our last question. Okay, the volume of a sphere increases at a constant rate of... Okay, this is the same concept, but I'm going to explain it, of course. Now the volume of a sphere, we know, is given by the equation 4 over 3 pi r cubed, just before like starting. Increases, so dv by dt is equal to 3 centimeter per second. When the radius is 4, they want the rate of change of the sphere, of the radius of the sphere. Now they want, so what do they want? The rate of change of the radius of the sphere. So dr by dt. Now what else do we have? We have dv by dr, which is the derivative of the equation of the volume. So it is just 4 pi r squared. Memorize it at this point, the derivative. So what did I tell you before? You always start by the rate of the volume or surface area, the big one. So dv, you're always going to start with dv over dt equals dv by dr times dr by dt. Always start with the rate of the volume or the surface area. So dv by dt we know is 3. dv by dr we know is 4 pi r squared. Now we need what is dr by dt. Oh wait, we were given it. We were given that dr by dt is 3 over k pi. They want what's pi, so this is dr by dt. So now we substitute this by 3 over k pi r. Now what do? We substitute all our r's, or first let's write the equation. So we need to move this on one side and leave the thing with k on the other. So it's 3 over 4 pi r squared equals to 3 k pi r. Now let's substitute r into these equations. So r is 4, so we're going to replace this way by 4 pi r pi k. And this we're going to replace it by 4, which is going to be 4 squared is 16. 16 times 4 is 64 pi. Oh wait, they didn't tell us. My bad. I don't know where I got the 4k pi from. It's just k pi. So they gave us it is k pi. I don't know where I got this r from. My bad. So now 3 over 3 is the same. 64 and there's k. So k is equal to 64. And that is your final answer. That is it for this quiz. I hope you understood everything. Have a great day. Bye.